Did you know that the average car today contains over 1.5 kilometers of wiring? Some luxury models even have more than 3 kilometers. That's right, your car is practically a moving data center, and this complexity comes at a cost. But it's not just about having more wires, it's about why they're there and what it means for your car's performance, maintenance, and of course, your wallet. Today, we're going to break down why your car's wiring is becoming more complicated and more expensive. Cars have come a long way from their humble beginnings. In the early days of automotive history, vehicles were mostly mechanical marvels, with only a few simple electrical systems for essentials like ignition, lights, and maybe a horn. These systems were crude and minimal, just enough to get the job done. But today, cars are packed with electronics. From advanced safety tools like automatic emergency braking to modern conveniences like voice-activated controls and Wi-Fi hotspots. What we don't see is the complexity lurking beneath the surface, the intricate web of wiring that holds everything together. Today's wiring systems don't just provide power, they carry data between computers, sensors, and actuators in real time. This level of sophistication means more weight, higher repair costs, and maintenance challenges. But it's a long journey from the simple beginnings of car wiring to today's complex systems. Let's rewind to the early 20th century and explore how it all started. Let's rewind to the early 20th century and take a look at the Ford Model T, the car that revolutionized transportation. When it first hit the roads in 1908, the Model T's electrical system was about as simple as it gets. The car didn't even have a battery or starter motor initially. Instead, it relied on a magneto to generate electricity for the ignition system, and drivers had to start the car manually by cranking the engine. The wiring in these early cars was minimal, just a few copper wires covered in cloth insulation, connecting the magneto to the ignition and the headlights. The cloth insulation was primitive and prone to wear and tear, particularly when exposed to moisture or oil. Over time, the insulation would deteriorate, increasing the risk of electrical shorts and failures. Despite its simplicity, this early wiring system was the beginning of something much bigger. Over time, cars began incorporating more electrical components, things like electric starters, horns, and more complex lighting systems. By the 1920s, the Model T evolved to include a battery and starter motor, which meant more wires and more complexity. And this was just the start. Fast forward to today, and modern cars are equipped with a dizzying array of electronics. One of the major reasons behind this explosion in wiring complexity is the rise of advanced driver assistance systems, or ADAS. These systems, like lane keeping assist, adaptive cruise control, and collision avoidance technology, rely on networks of sensors, cameras, and processors that need to communicate in real time. To keep everything running smoothly, these components are connected by miles of wiring, creating a web of complexity. And then, of course, there's the rise of electric vehicles, or EVs. EVs may have fewer moving mechanical parts than traditional internal combustion engine cars, but their electrical systems are significantly more complex. EVs have high-voltage battery systems, regenerative braking, electric motors, and a host of onboard electronics. The wiring in EVs needs to be highly specialized to handle not only the high voltages but also the unique needs of energy management. These wires are thicker, more heavily insulated, and far more expensive to produce and maintain. It's not just safety systems or powertrains that have contributed to the rise in wiring complexity. Your car's infotainment system is another key player. From voice-activated assistants to built-in Wi-Fi and Bluetooth, modern cars need to handle vast amounts of data. Fiber optic cables are increasingly being used to carry that data faster and more reliably than traditional copper wires. These advanced wiring systems not only require more space but also bring with them a new level of complexity in terms of repair and maintenance. Back in the early days of car manufacturing, the materials used for wiring were simple: copper wires with cloth or rubber insulation. While this might have worked for a few basic components, these materials weren't built to last. Rubber insulation could become brittle over time, especially when exposed to heat, while cloth insulation offered very little protection from moisture or chemicals. These early materials were vulnerable to fraying and cracking, which increased the risk of electrical fires or short circuits. By the mid-20th century, advances in material science brought more durable options. Polyvinyl chloride, or PVC insulation, became the standard for wiring, offering greater heat resistance and better protection against wear. In today's vehicles, the insulation materials have become even more advanced. Engineers use polymers like polyethylene and thermoplastic elastomers, which offer high resistance to abrasion, chemicals, and heat. These materials allow wires to be thinner while still providing superior protection, enabling manufacturers to pack more wiring into smaller spaces. The evolution of materials didn't just make car wiring more reliable, it also made it more flexible, literally and figuratively. Modern cars have increasingly complex wiring harnesses, which can contain hundreds of individual wires, all color-coded and bundled together to save space. In many ways, these harnesses are the car's nervous system, sending power and data to every part of the vehicle. Let's take a closer look at one of the most advanced wiring systems on the road today, the Tesla Model S. Tesla's electric cars are celebrated for their innovation, but this comes with a price, both literally and figuratively. The Tesla Model S has one of the most complex wiring systems in the automotive world. Why? It's not just the high-voltage battery systems, but the fact that every sensor, motor, and onboard computer needs to communicate in real time, often through miles of wiring. Tesla's wiring system is a web of data-carrying cables. When something goes wrong, even tracing the fault can require hours of labor, as well as specialized diagnostic tools and software. And Tesla isn't the only company facing this issue. High-end luxury brands like BMW, Mercedes, and Audi are all grappling with similar levels of wiring complexity in their top-tier models. When repairs are needed, it's not uncommon for labor costs to skyrocket due to the time and expertise required to fix these systems. As car wiring systems become more complicated, the financial impact is being felt by both manufacturers and consumers. Repair costs for electrical issues have doubled in the past decade, and finding mechanics who can handle these complex systems is becoming more difficult. Specialized training is required for technicians to work on the high-voltage systems found in EVs or to trace faults in ADAS wiring. For manufacturers, the cost of producing these intricate wiring systems has gone up as well. Wiring harnesses are now custom designed for each car model, often. So, what does all of this mean for you as a car owner? It means that car wiring systems are going to keep getting more complex as technology evolves. Understanding that complexity can help you make better decisions when buying and maintaining your vehicle. Yes, these advanced systems offer more convenience, safety, and entertainment than ever before, but they also come with higher costs, both upfront and down the line when repairs are needed. As consumers, it's important to weigh these factors carefully, especially when purchasing a new vehicle. Being informed about the hidden complexities of modern car wiring systems will give you a better understanding of the true cost of ownership. So, what do you think about the rising complexity of car wiring? Have you had any experiences dealing with expensive electrical repairs? Drop your thoughts in the comments below. And don't forget to like and subscribe. Check out our next video, where we'll give you some essential tips. Thanks for watching.